Boa tarde, pessoal! Agora teremos a palestra do professor Humberto Bustince. Todos convidados para o auditório. Vamos lá.
No sé. Sí. Ahora no. A ver, espérate, que se oiga bien, porque si no, tenemos...
Eu que desliguei aqui, tá? Eu que fechei o áudio dele aqui. Que tá saindo na live. Quando for para ele falar, eu abro.
No va, ¿eh? Ahora sí. Ahora va. Vale, venga.
Posso começar? Ah, não está na hora ainda. Ah, temos 3 minutos.
Boa tarde, pessoal. Vamos então começar a nossa quarta palestra do evento. Tá? Vou passar aqui a palavra para a professora Jafelice apresentar o nosso palestrante.
É uma honra para mim apresentar o professor Humberto Bustince, que tem um extenso currículo, e vou fazer um resumo aqui, né? Humberto Bustince é fellow da Sociedade de I3E, Computational Intelligent Systems Society, é membro do board do EOSFLAT, European Society for Fuzzy Logic and Applications, and fellow of IFSA, International Fuzzy System Association, associação da qual ele também foi presidente no último ano, né? Ele é autor de mais de 500 trabalhos
300.
publicados em journals, né? E conferências, e por seus trabalhos ele está na lista dos 2%, né, dos cientistas mais influentes do mundo em todas as áreas. Editor da revista Mathware Soft Computing, que é publicada pela EOSFLAT, e também do periódico Axioms. Ele é professor honorário da Universidade de Nottingham e, recentemente, também recebeu o título de professor honoris causa da Universidade Federal do Rio Grande do Norte. Recebeu muitos prêmios, entre eles, os mais importantes foi em 2015, ele foi condecorado com a Cruz do Carlos III pelo governo de Navarra, onde fica a Universidade Pública de Navarra, onde ele trabalha. Em 2019, ele recebeu 2 prêmios importantes. Um é o Prêmio Nacional de Informática e o outro é o Prêmio Europeu de Lógica de Fuzzy. E, em 2025, agora recentemente, ele recebeu o Prêmio Nacional de Supercomputação. Certo?
Ok.
E, mais importante que todos esses prêmios, ele foi condecorado agora num workshop que a gente fez ali na UFRN em homenagem a ele, né, como o principal operador de agregação do mundo, né? Okay. Ele agrega amigos, agrega colegas, pesquisadores, estudantes, né? Distribuindo essa luz que ele tem, né? Toda hora ele está chamando, vem esse trabalho para ti, vamos fazer isso, né? Então, aqui está Humberto Bustince.
Well, thank you very much, Grasaliz, but I want to say, firstly, some things. Firstly, Arratsaldeon denoi, in English is, well, good afternoon, everyone. The previously is in Basque language, and gracias a todos por venir en español. I will speak a little bit in English, other times Spanish, not Euskera, Basque language not, it's complicated. But, well, I want, in the first place, to give thanks to the organizers for inviting me to be here. And the objective of this presentation is to show some new methods for aggregating data for artificial intelligence. It is very important to say the following. The data are the food of the artificial intelligence. Without data, we have not anything. And also, we need to do continuously fusion of this data for decision making decisions. This is the idea. Every day, we do a lot of times fusion of our data. But I will present here only some applications or some fusion of data in artificial intelligence. In particular, I will start with the convolutional neural network. Well, this convolutional neural networks arises in 2012, more or less, and the idea is very simple. There are 2 operations from a mathematical point of view. The convolution, I will compare this image with a set of images, in particular filters 64, more or less. As a result of this similarity between these images is another new image. Please, it's not a number. This is important. Next, the second process, the second step is always to do a fusion of data for reducing the size of the image considered. This process is the pooling process. For this reason, in neural networks, the method for making fusion of data has the name of pooling process. It's the same. Well, not always in the same. Here, when we work with pooling process, I will use only real numbers. However, in aggregation, usually we use numbers between 0 and 1. And also, I want to say the following. In large language model, for example, each word is a vector with more or less 300, 500 numbers. And we will use always numbers for representing all things, as vectors, matrices, etc., etc. Well, here I will present some process for obtaining the best image from this image, the best reduction. But when we are working, I insist with real numbers. But in our life, there are other representations. For example, in this case, in my topic, I will speak later about the computational brain. It's very important. In this case, the data are really intervals in the following way. I will put to a person an electroencephalogram, and I will ask a question such that the answer should be yes or no only. For example, could you move the left hand? And I will take, in this case, 8 wavelengths, yes, data. But the problem is the following. Here we have this electroencephalogram. The brain is inside, and there is a distance between the electroencephalogram and our brain. And then we have noise. We will represent this noise using intervals. I will put this point, and I will construct an interval such that the length of the interval will be a representation of the noise associated with this point. Finally, I need to do an aggregation of intervals. In this case, I will represent the data using intervals, but I insist, in large language model, the data, the words are always vectors. Then there are different methods for representing. No problem. I have finished. I will speak later about this. Well, then I will use, in the first place, numbers for representing our data, numbers between 0 and 1. When we want to work with real numbers, I remember here Tiago is the father of this expression for interchange, no? Numbers between 0 and 1, or real numbers, etc., etc. This is the idea. In the first part of my presentation, the data will be numbers between 0 and 1. More thing, what is the main idea is the following. We have n numbers. I will take one number for representing the previous set of n numbers. This is the classical idea. This is the classical idea given by the name of function with n arguments. I will take n numbers, and I will take only one number for representing the previous set. Depending on the context, I will impose different properties to these functions. For example, sometimes I will ask the property of the monotonicity, very well known by us. I will speak later about the problem of this property. It's very important property, but with some specific problems. More things about this. In 1980, taking this idea into account, the concept of aggregation function appears in the following way. I will take n numbers, and I will take these numbers, I will take a number between 0 and 1 for representing this set of numbers with these conditions, the monotonicity and these border conditions. Under this interpretation, if we have a set of n numbers, if all numbers are always the same, I will take, for representing the previous set, the same number. This is the idempotent property. And in 1984, more or less, Fodor and Rubin, among others, proved the following. Every aggregation function with this property is an averaging aggregation function. The result is always a number between the minimum and the maximum. I insist, we are working with numbers between 0 and 1. This is important. Examples of this type of aggregation functions. We have the T-norms, very well known by us. They are bivaluous functions with these properties, in particular the associativity property. These properties very complicated for big data. These functions have been very used for representing the conjunction and in fuzzy logic. Examples, we have the minimum, the product, the hammer tenor. Giancarlo is here. You know that in classification, in some specific parts of the Ishibuchi algorithm, the best results have been obtained using this tenor. I insist, the main property is the following, the associativity. If we have a definition for 2 arguments, we can extend this definition for 3, 4, etc. However, in big data, for representing the conjunction, and these functions are very bad, are worse than the following, the geometric mean. But the geometric mean is not associativity. For this reason, the concept of the overlap functions appears some years ago, in 26, 27, in collaboration with Grassalis, etc., Benjamin, etc. They are also bivalve aggregation function with these properties. Obviously, this is important. Every continuous tenor without divisors of 0 is an overlap function. Example, the product and the geometric mean. These functions have been very important for big data and also for constructing measures for measuring the quality of a partition, of a classification. Well, the dual of a tenor with respect to an strong negation is a Tycho norm. The dual of an overlap function is, with respect to a strong negation, is a grouping function. And also, I need to consider, by first time here, the possible weight of the different data. I will remember here the concept of overlap OA operators given by Jaeger. We have a set of numbers for aggregating. I will order in a decreasing way. I will take a vector of weights, and I will multiply this the highest value by this value, etc., and this is the OA operator. I don't want to speak about OA operators, only to say the following. We consider here the weight, the importance of each data. Up to now, all things are very well known by us. We have no problem, or it's fantastic, but there are some important problems. The first of them, usually the data are not independent. There are collisions between the data. For example, if I want to buy a car, the price and the Jafelice, the security, are completely, there is an important relation between both, no? Price and the security, etc. And for this reason, up to now, one method for representing the collisions between the data are the fuzzy measure. I will remember here the concept of fuzzy measure when we are working with numbers between 0 and 1. The real definition was not given in this way. But when we are working with numbers between 0 and 1, the fuzzy measure is the following. Given a set, for example, of 3 numbers, I want to calculate the fuzzy measure. That is, I want to calculate the collaboration previously of each element to the whole set. Secondly, the collaboration between 2 of them with respect to the whole set. And finally, the whole set with respect to the whole set. If we have 3 numbers, I will consider this set 1, 2, and 3 with independence of the numbers for aggregating. I will construct all subsets of this set 1, 2, and 3. For each subset, I will take a number between 0 and 1 with this condition, the monotonicity. If this subset is a subset of y, then the fuzzy measure of this is less than or equal to the fuzzy measure of this. And these border conditions. The fuzzy measure of the empty set is equal to 0, and the fuzzy set of the whole set is equal to 1. I insist. For example, one subset of 1, 2, and 3 is, for example, 2 and 3. The fuzzy measure set the coalition or the relation between the second data and the third data. This is important. If we have, for example, a set with n elements, a football team, we have 2 n's, a big number of collaboration. And we can consider, for example, the relation between the portero and the delantero uno. The portero and this is the idea. We can calculate this fuzzy measure in different ways. For example, without considering the data for aggregating. We have this. Usually, Giancarlo knows, we will calculate this is the cardinality of the subset considered. This exponent Q is calculated using genetic algorithms, but usually always the value is Q equal to 2. I don't know why. But we can calculate this fuzzy measure considering the data for aggregating. I insist, up to now, the most important representation of the coalition between the data are the fuzzy measure. Taking this definition into account, I will remember quickly here the concept of shocked integral, discrete shocked integral, and Sugeno integral. The shocked integral, please. I will take a fuzzy measure for calculating the coalition between the data. Secondly, I want to aggregate this value. These are aggregation functions for the reason Grassalis previously said, the aggregator of the different things, people. Well, I want to aggregate these values. I will order in an increasing way, and I will calculate the shocked integral in this way. Important facts. Here I have a difference, but when we are working with intervals, we go outside of the interval 0, 1. But when we are working with numbers, without problem. This is an aggregation function, and idempotent, homogeneity property satisfies, if invariance, comonotonicity additive, it's all properties. The result is always a number between the minimum and the maximum. There are important papers studying this type of functions. Here, there is a representation. In the horizontal line, I have the values in an increasing way, the values of the fuzzy measure, and this is the idea of shocked integral. Currently, the most important the most used integral is the concept of Sugeno integral. The advantage of this definition is the following. Sugeno presented his integral using real numbers. But in this case, I will take again the classical fuzzy measure. I want to aggregate these values, and then I will order in an increasing way, and I will use this expression. Perfect. Idempotent, averaging, the result is always between the minimum and the maximum. These integrals are the most popular integrals in the case of using of this fuzzy measure. Another thing, please. In the definition, previous definition of shocked integral, the fuzzy measure, well, I have imposed here this condition, but not always it is necessary. When we remove this condition, the name is capacity, measure of capacity. Currently, is the people uses always capacities. This is important. It depends, obviously, the method used for constructing the fuzzy measure. Well, this is a resume of the most important aggregation functions studies up to now. There are important papers with important properties, and for me, it's important. But I will start with the first problem. In our definition, I have imposed the monotonicity, but the question is why? I have not why. Really, I will speak in convolutional neural network that the monotonicity is not important. However, well, there are some applications where we don't need the property of monotonicity in the following way. In Australia, Tim Wilkin and Gleb Yakov, in a project, they try to study the evolution of the cracks in the world. Well, they have very good algorithms, but they observe the following. If in these algorithms we use the mode instead of the classical aggregation function, the results obtained are better than the results obtained with aggregation functions. But the mode is not increasing. Then we have a problem. In 2015, they decide to include the mode in a specific type of aggregation functions, and they define the idea, well, there are more things, the idea of monotonicity with respect to this vector, with the name of weak monotonicity in this direction. This is the mode. The same year, a set of researchers, in collaboration with Rasco Messiar, etc., we present the definition of the monotonicity in any direction. The same year, only 3 months of difference between the papers. Then both groups, research groups, are working the same idea in different countries, Australia, Slovakia, and Spain. And then we have this definition, important for us. I will take a real vector. Components, real numbers. Secondly, I will say that this function f with the idea a set of numbers will be replaced by only one number. We will say that this function is increasing with respect to this direction when this inequality holds. Important. This is a vector, this is another vector, and this is a constant greater than 0. Obviously, if we take as vector R 1, 1, 1, we recover the definition given by Tim Wilkin and Glebeliakov with the name of weak monotonicity. The advantage of this definition is the following. We can include here the implication operators. The implication operators have been used for representing the fuzzy rules in fuzzy logic, no? And these functions are decreasing in the first argument and increasing in the second. Then they are minus 1, 1 increasing with this definition. This is very important. We can include different versions of the different aggregation functions replacing some operations for recovering monotonicity with respect to a direction R. I don't know, my origin is physics, and the first ideas I thought, well, this is very old idea, no? I suppose that some years ago, 100 years ago, etc., some people studied this property. No, was the first time, in 2015. Well, now, taking this idea into account, in the definition of aggregation function, I will replace the monotonicity by the concept of monotonicity in one direction, R, and then we obtain the definition of pre-aggregation function studied with Giancarlo, Thiago, etc. from Brazil. All from now on, at the end, in every paper, there is at least one person from Brazil. It is important, this collaboration. It's for me very important. Well, in fact, this was published in this year, etc., etc. The origin of the next application is different, but I will study now aggregation functions and pre-aggregation functions. The name, important. Bernard de Baez said that the name is not a good name, but the idea is the following. Every aggregation function is always a pre-aggregation function. However, there are pre-aggregation functions such that they are not aggregation, for example, the mode. The same as more or less the order and pre-order. Bernard de Baez said that the name should be monotonicity with respect to a direction R. Aggregation with respect to a direction R. It's not important. Well, now I will present some specific functions for aggregating, for making fusion of data, using not only aggregation functions, also we will use pre-aggregation functions, monotonicities in one direction R. But I will not present here the PhD thesis of Giancarlo using the generalization of the Ishibuchi algorithm for classifying. It's very good algorithm. Now, in the last workshop in Canada, the people from Japan said the following. The advantage of this algorithm is this algorithm is explainable. It's important. However, the classical machine learning, etc., is not explainable. This is the problem. But, well, in any case, the origin of the following expression is really in the algorithm of Giancarlo, but he studied these conditions with socket integral. I will use here only Sugeno integral in this part. The idea is very simple. As I have said before, this is the socket integral. We want to aggregate a set of n numbers. I will take a fuzzy measure. It depends, but I will take a fuzzy measure. Who is the best? I don't know. What is the best fuzzy measure? I don't know, but I will take a fuzzy measure and I will use this expression for calculating the aggregation of these numbers. First idea, this is monotonicity, etc., etc. I will replace the minimum by one function m. But depending on the function m, the result is aggregation or no, is a pre-aggregation. Well, the first work, a long time speaking with Radko Messiar, he said, no, this is not possible. However, the reality is the results obtained with socket integral replacing the fasting measure by, the minimum by the function m, the results obtained in an experimental case are the best. And then finally, Radko works with us in these extensions. Well, in this case, I insist, I will use not the socket integral, I will use the Sugeno integral. I will replace this function by one function m under these conditions. The idea is to recover always at least a pre-aggregation function. This is the idea for any fasting measure. Well, if we use as m a function, an aggregation function, we recover an aggregation function. Under these conditions, we recover only pre-aggregation functions. And I will apply this problem, this new function, is the problem of the computational brain. What is the origin of this problem? Important. In 2015, I arrived to a workshop in Naples, FASI IEEE, I remember. In this workshop, I presented a new method for aggregating data using socket integral with different functions instead of the minimum. At the end of the presentation, Sitten Link from the Polytechnic Institute of Australia told me, please, is it possible to work with you with these aggregation functions in the problem of computational brain? Obviously, I said yes, but firstly, we need to know what is the problem, what does it mean. This is the idea. The problem is very simple. I will put an electroencephalogram to a person in this way, as I have said before, no? Well, I will repeat. And I will put the electroencephalogram, and I will ask, please, could you move left hand? I will take these values, I will transform these values in intervals, and I will aggregate. I will repeat the process, this process with each person at least 100 times. Now, could you think to move again left hand? Now, could you think to move right hand? At the end, with this person, I will aggregate the values when this person thought to move left hand and when this person thought to move right hand. I will repeat the process with more or less, I remember, 5,000 people. And at the end, I will aggregate all things when these people thought to move left and all people thought to move right. Now I will take the electroencephalogram, I will go to a street, I will put the electroencephalogram to a person, and I will ask the following. Please, could you think to move left of right hand? And I should guess. This is the problem. We start with accuracy more or less 70%. With the socket integral, the results obtained are not good. 1 year working, 2 days per week, more or less, at 6 o'clock in Spain, in collaboration not only with Australia, also with Taiwan. Part of the group of Sitten is in Taiwan. We decide to use, instead of the socket integral, to use the previous Sugeno integral with different functions. And then we obtain different results. This is the experiment. Well, in any case, well, as we will use, firstly, the classical Sugeno. Secondly, the Sugeno replacing the function, taking as function m, the Hammaker-Tinor. And finally, in this case, well, the results obtained more or less with these expressions, in particular with Hammaker-Tinor, more or less 94% of accuracy. Incredible, without intervention. Elon Musk used intervention in our brain. Here, no. Very good, but when we publish this paper in collaboration with Grassalis, etc., you also know? No? Well, Grassalis, yes. In IEEE Computational Intelligence, the people from Taiwan decide to use the following video in this way. In this way. Now, the computer asks this person, please, can think but cannot speak. This person can think. The computer asks, do you want to eat? If the person thinks yes, then this bad, very bad robot take food and give the food, etc. This process is, there are different repetitions until the end. When this person decides, no, I don't want to eat more, then the process stops. When we published this video, a lot of people wrote me saying the following: I have a family with Alzheimer. Is it possible to use? No, please. The person can think. This is the idea. Well, now I will do some comments. What do you think, what is the best result when we repeat the process with the hands and the feet? Probabilistic results. We don't know why. We have an exceptional tool, our brain, but we don't know why we cannot repeat the process using the feet also for things. It's impossible. But this experiment has been done by any people. I take you the electroencephalogram, I put, and next I repeat with Benjamin. But for example, for solving the problem of the ictus, what is the translation, ictus? Well, the experiment is only by only one person. We repeat a big number of times the same experiment with a person. We can move the hand of a person with this ictus using skeletal. Well, I don't remember exactly, but this is only a method for one person, and this is a method for every people. This is the idea. The results are very good, and this experiment justifies to use, instead of the minimum, a T-norm, in particular, Hamaker T-norm. This is the idea. Well, more things. Now I will apply this in convolutional neural networks. The idea is more or less the same. I will repeat here some very well known by us definition, the arithmetic mean when we are working with real numbers. Why? The pooling process, in the pooling process we use real numbers, and then we will use real numbers. Well, I present here the real definition given by Sugeno. This is the definition of fuzzy measure. Well, fuzzy measure really is the measure given by Sugeno. As you can see, we change this interval, and we have not here the value of the fuzzy measure when we are working with the whole set. It's not the maximum. And here I present the definition given by Sugeno, the maximum or the minimum. It's the same definition, but using real numbers. More things. I will replace in the definition given by Sugeno the maximum by one function g and the minimum by another function f. And finally, I will apply these functions in convolutional neural networks. But what is the problem? The problem is we observe the following. We don't use the whole real numbers. We use only a part of real numbers, and then we construct the definition for this type of subsets. And here I present the corresponding definition and the corresponding definition of Sugeno integral in this way. But, well, idea. I will use different functions in between them, this function, the sum, as g, and different functions by representing the function f, the product. Well, I will take firstly the product. We have proven a lot of different functions, but when we use these functions, I will represent the Sugeno integral, the Sugeno expression obtained, the expression obtained from Sugeno integral in this way. Now we come back again to the convolutional neural networks, and we have this situation. I have an image, the convolution. The convolution was given by Einstein. It's very old operation, sum of products. And I will do a pooling process for reducing the size of the image in this way. In 2012, the first paper for distinguishing between cat and dogs, they used the maximum for replacing these four values by only one. In this case, the maximum is this, In this case, the maximum is this value, this and these values. The maximum. In 2015, the other authors, decide to use instead of the maximum the arithmetic mean in the process of the pooling. What is the coincidence between both functions? The maximum is increasing and the arithmetic mean is increasing. Then we will use the definition of functions increasing in our sense when we will aggregate values, real values, and we represent here, I will remember here the statistic orders, the order statistic, etc. They are increasing functions. We know perfectly this theory and we have no problem. Well, as I have said before, the first paper used the maximum. This, the maximum, the maximum, the maximum, and the maximum. 3 years later, the averaging. But in 2017, a paper appears saying the following: I will use a combination of the maximum and the averaging, and the results obtained are the best. This year, reading this paper, I have spoken with my student Josu Rodriguez, and I proposed him to do a PhD thesis replacing the pooling by combination of different aggregation functions using always increasing functions. Then the idea is the following: I will take different functions, I will construct this combination, and I will study the condition under which this function is increasing. Well, when we use, I will represent it this way, no? When this function is increasing, perfect. The only reason is the following: the maximum and the arithmetic mean are increasing. The combination is also increasing. We prove that the following: if we use as functions for making the pooling process the order statistic, in this way, if each argument is greater than or equal to 0, this expression is increasing. If we use the arithmetic mean and the order statistic, under these conditions, we obtain a combination increasing. If we use the order statistic, and the Sugeno classical for real numbers, under these conditions, our combination is increasing. If we study the arithmetic mean and the classical Sugeno integral, under these conditions, we obtain a pooling aggregate or pooling function increasing. And finally, if we use the combination with our expression, using instead of the maximum the sum and instead of the minimum the product, under these conditions, we recover increasing combination. And if we aggregate the arithmetic mean and our expression obtained from Sugeno integral, under these conditions, we obtain increasing functions. And then the new expression obtained from Sugeno and the Sugeno, under this condition, our combination is increasing without problem. Very simple problem, no? We present this, we study these combinations in the following experiment. We will use these 3 architectures, very well known. And now I will use as data set Cipher 10 in these conditions, training image, test image, etc. The results obtained. There are 2 types of experiments. Firstly, in the polling process, I will use only individual functions. This, arithmetic mean, maximum, minimum, median, Sugeno, and our generalization. And in the second experiment, I will use combination of these expressions. When we use in only one function, in this case, in the second architecture, we are the winner with a generalization of Sugeno. Maximum, sum instead of the maximum, and product instead of the minimum. When we do combination, always we are the winner using our generalization, also in different combination. We submit this paper to the Neural Network Journal, the most important in this topic, and the one referee told us, and why the pooling process should be increasing. For example, I have here these functions, they are not increasing, and the result is good. Then, in the pooling process, it is not necessary to impose the condition of increasing monotonicity. We publish, we prove some other properties, and finally we have published these results in the same journal, etc. But I insist, it is not necessary to impose the condition of classical monotonicity in the pooling process in convolutional neural networks. In any case, using always these functions, that is, instead of the maximum in Sugeno, and we put the sum, and instead of the minimum, we put the product, the results obtained are the best. This is a result very important. This has been published in this paper, etc. Well, I have spoken a lot, up to now, please. Ideas. I don't want to bore you. The idea is the following. The original definition of aggregation function has important problems. One of them is the monotonicity. And another problem is we need to study the collaboration between different data. We have used up to now the classical phasing measure. And also we have observed some problems with the monotonicity. We have solved some of them using pre-aggregation functions, etc. But up to now, we have used always the classical definition of phasing measure with real numbers or not. But this definition has an important problem. It's the following, the magnitude. If n is very big, the number of subsets for calculating the phasing measure is increasing. Computationally speaking, is impossible. In big data, it has been impossible to use this definition of phasing measure. Taking this idea into account, we will replace in Sugeno integral the phasing measure by different functions. In particular, we will replace this function, the phasing measure, by one function considering always n minus 1 arguments. That is, as many numbers for aggregating minus 1. In this case, if we take, for example, this, we need to order in an increasing way. This is the third term. I will use as argument of this function the first, the second, the fourth, etc. Not the third term. And the name is Sugeno-inspired function. This paper has been published this year. This paper have been published this year, more or less. And I insist, always in this paper there are at least one or two people from Brazil, always in collaboration with Brazil. An example, n should be equal to 3 in this case. Well, we want to aggregate these values, I order, and this function, in this case, is the arithmetic mean. We take this value and the arithmetic mean of the rest. We take this value and the arithmetic mean of this one. This is the classical definition of Sugeno integral when we replace the phasing measure by this type of functions. Another thing, I will put here the definition, please. The function f should be increasing for us. We can speak later about if we impose the symmetry, the condition and the definition is completely different. I will impose only the monotonicity, and I will replace the phasing measure by this type of functions. This paper has been also published recently in FastDZ and Systems. Properties. If I take here, please, instead of this as example of this function, the minimum, we recover here the minimum. If I take as function f equal to 1, sorry, no. If I take here, please, see, está bien, no? If here I put 1, I recover obviously the maximum. If here I take as function f the maximum, I recover this function. If I take, well, this inspired or Sugeno-inspired function is symmetric for any increasing function. This is an aggregation function if and only if this condition is holds. Well, this is an idempotent if this condition holds, etc., etc. One thing more, please. Important. In this definition, we can take different functions depending on the term. For example, this is the minimum value. I can take here f1. Second value f2. And the number of combination is permutation with repetition of n minus 1 taking n minus 1 times. The complexity from a computational point of view is very big. It depends. We can use always the maximum. Why not? no? But it depends. Well, this a new definition, but always we introduce a new concept. We need to justify why we will use this new concept. Yes, okay, I have time. I will justify, no? The reason is very, well, one possible application. I will not speak here, I have no time. We have used this expression for constructing measures for measuring the quality of a partition. We know what is a partition. It's a classification problem, no? We have a set of data. We will construct different classes under this condition. The union of these classes should be the whole set, and the intersection 2 by 2 should be equal to empty. Well, there are different methods, etc., etc. We use a method for constructing these measures, etc. When we submit this paper to the journal, with this example for justifying our new definition, we present this, but this one is more easy to see here in this definition. Here I will use as function f the weights given by Jaeger. Numbers between 0 and 1, the sum of the weights should be equal to 1, etc. And the referees told us the following. If you put here, as the answer was the following. In this page, you use here the weights. Okay. Please, could you read the paper written by Dubois, Pratt, and Testemel in 1986? It's the same definition. Then we have obtained a new generalization of the idea given by Didier Dubois. This is the idea, replacing this by the weights. Then this is the justification for studying this type of functions. Not only the method for constructing a specific, this is the previous definition, for constructing a specific measure for measuring the quality of a partition. This is the idea. Well, the results, obviously, we need to compare with classical indexes. The results are good in blue color. Not the best, please, it is important. There are measures better than this measure, but the recovering of the expression given by Dubois was the justification. For Dubois uses these expressions in other applications. And finally, I will speak about the shocked-inspired function. The idea is the same. I will use here, well, also Grassalis and some members, Radko Messiar, etc. I don't remember Resnivan, Benjamin, etc. We have used instead of the difference the dissimilarity. Why? The reason is very simple. When we are working with intervals, for us it's better to calculate the dissimilarity between two intervals instead of the difference. Well, we will replace here the fuzzy measure by one function, but in this case I will use n minus 2 arguments. These arguments are not considered. Example, we have this. If we have 4 numbers for aggregating, we order in an increasing way. I take the minimum value, the second minus the minimum, by the argument of these functions is the third and the fourth. That is, this one not. Here, 3 minus 2, 1 and 4. That is, this not and this not. Again, a new consideration. We can take different functions, f1, f2, and f3, etc. This paper has been published also in this 3 months ago, no more far, with Bernard de Baez, Radko Messiar, Grassalis, etc., and different people. And this is the correct definition. We will take a restricted dissimilarity function, and we'll take this function f without conditions, and we have this expression. We have studied theoretical properties. Always, if you are working with socket integrals, it is important to study the homogeneity, the safe invariance, and the comonotony additive. the additive comonotonicity. We have studied the conditions under which these functions are homogeneous, Sieve invariants, and the comonotonicity additive. Not important. We have used these expressions for making a reduction of the size of the image. In this way, we have applied using different functions F for obtaining good results, and the best results has been obtained depending on the noise used with the shocked integral inspired in this case, and the rest with the arithmetic mean. Now we will combine this and this for applying in convolutional neural network in this architecture, and the results obtained are good, but not good enough. Are good, not, but I insist. Why the results are not good enough? The idea is very simple. The idea is the following. Please. In this definition, in this and the same as in Sugeno, if we use this expression for aggregating a few, well, for example, a few numbers for aggregating, only the number for aggregating is not very big, we can calculate the fuzzy measure in an easy way. But if we have a big number of data for aggregating, now we cannot calculate the fuzzy measure, and then we can use this expression. In Sugeno inspired and shocked inspired, this function should be used only when we have a big number of data for aggregating. In another case, we can use the fuzzy measure. For this reason, in the expression, in the application of this, the shocked inspired in this architecture, we will replace 4 values by only 1. We can calculate the fuzzy measure for 4 values, but however, if we have 100 values, it's not possible. Then we should use this expression when we have a big number of data for aggregating. This is the problem. Well, this is the result. As conclusion, we have used, in this case, I insist, in shocked integral in the algorithm of Giancarlo. Here, in the computational brain, we replace the minimum by the Hammaker-T norm. The results obtained are the best. Second, the Sugeno, when we replace the maximum by the sum and the minimum by the product in convolutional neural network, the results obtained are the best. Sugeno inspired function, when we have a big number for aggregating, if we replace this by this type of functions, the results obtained are better than the results obtained with the fuzzy measure. And also the shocked inspired function, when we replace these functions, this fuzzy measure, by these functions, the results obtained are very good. Only one moment. Only three ideas. 3 more things. First one, we have used the Sugeno inspired also in convolutional neural networks. The results obtained when we use a reduction of the size very big is the results obtained are very good. In another case, not. Here I present the results. We have used also in natural language. And in natural language, please, in large language models and in natural language, for aggregating, it is necessary to have functions not symmetric. It's not the same like the house de. In Spanish language, le juzgaron y le mataron with a tenor T is not the same le mataron y le juzgaron. Then the first property of models, or LSTM, is the symmetry. This is very important. Well, we have the definition associated with this type of functions, etc. And finally, we have used these expressions in river overflow, where using Takagi-Sugeno process for calculating the weight. The results obtained are also fantastic. 10 hours before we can say to a person, please, could you go outside in a river overflow? Well, I have finished only. But I want to say one thing. Sorry, please. This is a comment. For me, it has been a surprise to visit you in Campinas. The reason has been my visit to the Sirius building. And my surprise has been the following. You are working in the protein folding. We are the first team in Spain that we have programming the AlphaFold 2 for protein folding. And in this process, for this reason, we have not only my hour about supercomputation of Barcelona Supercomputing Center some months ago. This is the origin of the work. But in this process, my team now is outside of the university. They have a company, etc. Use this type of aggregation functions. And for me, it has been a surprise to observe that here, there are people working in the same problem with the same ideas. It is necessary to develop, from a theoretical point of view, methods for calculating the similarity between image in 3D, this is the proteins, etc. It has been a fantastic visit for me, and I will give to this part of my team the email for speaking with the team working in this in Campinas. But in my team, they use classical aggregation function, not Sugeno and inspired, etc. Classical. No sé, lo he usado, no sé para qué. Bueno, esto es el final, sin más. Gracias por todo. I have finished at time? Yes, correctly. Okay, perfect. Yo estoy más cómodo hablando en español lento, pero bueno, creo que hay algunas personas, por ejemplo, yo trabajo bastante con personas como Bernard de Baes, Hani Hagras, antes se ha hablado mucho del tipo 2, aquí la presentación anterior, no sé dónde está la chica, que siempre imponen hablar de ciencia en inglés. Bueno, no pasa nada. Yo creo que cuando uno está cómodo con el idioma, el que sea, lo importante es entenderse, sin más. Entonces, bueno, si queréis alguna pregunta, si tenéis algo.
Thank you, Professor Bustince.
Many thanks for your presentation. Congrats. It's a very good way you use the other way to make a pooling. Yeah, I never been used it. My question is about the image embedding. Okay, do you know if we have some improvements in image embedding using CNN with the socket pooling?
Well, really we have had an important problem with the convolutional neural network. The problem is always the same. If you want to do experimentation, you need to have an important machine, GPUs, etc., etc. We have spent time with different processes, but we have studied only with these functions. Okay. I insist. The idea was in 2017 reading the paper about the combination of the maximum and the arithmetic mean. Okay. And then we decided to study combination of different fusion functions, not aggregation functions. Okay. And up to now we have studied only this method. However, we have used in LSTM different combinations, but I insist, LSTM are always for natural language in different ways. This is the A version, small version of LLM, this one, here. Yes, in this case, the best results have been obtained using socket integrals, but not inspired socket. The reason is that we will use only 3 vectors. When we use 3 vectors for aggregating 3 numbers, well, 8 values of the fuzzy method, but only this part. We have not more experimentation. It's complicated for us. I don't know your experience, but for me, the problem was always the same. Call by Barcelona Supercomputing Center, I need more computation, I need more experimentation, and also the referees, the reviewer of the papers, always the same. Could you prove with this architecture or with this data set? Yes. if you pay me the process, perfect. Do you understand? We have worked only in the pooling process.
Okay. Many thanks.
Okay.
Mais alguma pergunta?
Thank you, Humberto, for the presentation. Can you explain a little bit more about the application of pre-aggregation and the other functions you presented here in the fuzzy systems using Takagi-Sugeno inference?
Takagi-Sugeno, well, Grassalis is here. Well, I want to say the following. It's very complicated. I don't know why. There are communities working in a topic. When if you want to start in a community, it's very, very complicated. We have used, in this case, Grassalis said perfectly the problem, using in 2 different papers, but the method for calculating this instead of the T-norm, classically imposed by Takagi, etc., to use aggregation functions, in particular the shocked integrals, no? And the results obtained are very good. However, always, I will not speak more much this, always there is at least one referee saying, I don't know why. It's always the same. We have used for calculating these ways different aggregation functions, not Grassalis. We can speak a lot about this topic, but now I think that, well, we have 1 or 2 papers, more or less, published, and then the community is very close. I don't know why. In particular, the community for publishing in IEEE transaction fuzzy system. It's very complicated in this way, but the idea is to use, instead of the aggregation T-norm, by another application. This is the idea. We can speak later about the different modifications, etc. But always the referee. And in this case, yeah, there are a lot of papers of a very low level. However, now they are increasing. Yes, important in this. In my opinion, this is the best use currently of the fuzzy techniques. The advantage is the methods are interpretables, are explainables, are comparables, and I think that the results obtained with these techniques are very, very good. In fact, now we can use different neural, one first, second, another, etc.
A gente está com um tempo meio curto, temos uma última pergunta do professor Peter, e aí a gente passa para o mini curso depois.
Oh, thank you very much, Humberto. You used a whole variety of aggregation functions, and nowadays people are very interested in explainability. So I'm wondering why some aggregation functions work better than the others. And so you started out with saying, okay, people are using max pooling, average pooling, and both of them are increasing. And then you sort of tried out different aggregation functions, but and you showed different results. But can you explain why it works and why this specific aggregation function works better for this purpose than the other ones? And
well, it is my main problem. Benjamin has spoken about this problem in some papers. My paper saying the following: what is the best aggregation function? We have not the solution, but I know only 2 things. Not all data are the same, have the same value. Then it is necessary to use the weight of the data. Other thing is to calculate the weight. And secondly, always it is necessary to consider the coalitions between the data. If the measure used for representing the coalition, the results are always good. But what is the best methods for representing the coalition, there are not solutions. Then, what is our methodology up to now? We have a set of possible functions. We study different combinations. We spend a lot of time in computation, etc. And finally, we use the statistical test, and we decide when the difference is significant or not. Up to now, there is the only solution. From a theoretical point of view, it's very nice to study different properties, etc., etc. But please, if you study, for example, our inspired shocked integral is a theoretical paper. In application, if you have a big number of data, obviously the results are good. But the question is, are good enough? It depends on the data, the functions used, but I have not the solution.
I also seen papers with CNNs, for example, where, well, if you want to decide if this image is a cat or a dog or something like that, then what CNNs are doing are like feature extraction. So they're pointing out, oh yeah, I mean, this feature contributed to deciding that this is a cat, for example. And so they're trying to do some backtracking and trying to see what happens. So maybe something like that could be done in your case as well.
Well, only another thing, there are more parts where we need to do an aggregation of data, fusion of data, depending on the pooling, general pooling of a specific pooling. Depends on the data, yes. But I insist, usually it depends on the problem. Peter, it has been a problem in my last 3 years of my life. I would like to have a data set, and I will study the type of data, distribution of Gauss, distribution of different distribution. And then, do you remember your studies about what is the structure of the data set? Do you remember? For me, it has been impossible. There are different ideas, but it is necessary to implement these ideas and to know the results. If you have a small team, it's complicated. From a theoretical point of view, probably yes, but in the real life, you know, we have problems. Joelson, for example, Joelson is not here. He's working, people also from Pelotas, no? Working in transformers. Very nice idea. It's important, but we need to spend time and money in the computational proofs. And then, do you understand? No? For me, it's complicated to solve this type of problems from an applied point of view. From a theoretical point of view, always, is homogeneous, yes or no? Okay. We can speak later about this. I have read some things. It is very simple to write, but it is necessary. I remember that the day we received the answer of the reviewer about here there is this function is better than use function, but this function is not increasing. Okay. 2 years of my life.
Bom, pessoal, a gente pode continuar depois do debate. Agora nós temos o minicurso. Então, antes de ir para o minicurso, gostaria de agradecer mais uma vez ao professor Bustince pela palestra.
Gracias a todos los brasileños. Lo dije y lo vuelvo a decir, por mi equipo han pasado mucha gente, 100, 150 personas de Brasil. Ni uno solo ha dado el más mínimo problema y todos han contribuido de forma increíble a la mejora del grupo. Y además, tengo que decir, y lo digo, es una pena que no haya autoridades, con un nivelazo de preparación que ya lo quisiera yo para mis estudiantes. Thank you very much. Muchas gracias.